channel. Today's subject is COA, Computer Organization and Architecture subject. First unit. First we need to know what is CO, Computer Organization. It is a process of structuring and arrangement of various components for the computer system is known as a computer organization. Computer organization is the way of a computer system is structured, how the system is structured, what are the components are we used for arranging, what are the components are used, and how we are using the process of a structure to implement some tasks in architecture is known as a computer organization. Structured to implement the specifications, doing functions of computer architecture. This is the one definition. Another definition, the way in which various components of a computer system are arranged and connected. How the components, computer system components, how they are arranged, how they are connected from one device to another device is known as a computer organization. The way of connecting various components and how the arrangement is done, how the structure is used for implementing the specifications is known as a computer organization. Computer design. It is a process of designing the hardware components. Computer design is concentrated hard on the design of the computer. Once the computer specifications are formulated, the next task is to design or develop the hardware of the system is known as computer design. It is a process of designing the hardware components for performing the task or for developing the hardware by using system is known as computer design. They will ask for difference between computer organization and computer design. It is in our video. It is in description. It is important for 5 mark. If you not watched it, once go and watch it. Please subscribe to Sarifut YouTube channel. Computer architecture. It is a process of behavior of a computer by the user is known as computer architecture. Computer architecture, it is concerned with the structure and behavior of the computer as seen by the user, how the user is using the computer, how it is structured, how it is used. Behavior is known as a computer architecture. It includes information format, it includes some information and a structure, instructions, addressing memory techniques, specifications for processor and memory is known as computer architecture. These are the subtopics. They will ask like 1, 2, 3 for 5 marks, and it is important for 1 mark question also. Better to know all the topics for attempting the questions. Better to know all the topics. Watch the full video. I have covered all the important topics in previous year questions. Digital computer. It is a process of computer representation and computer variables and computational tasks, how we are performing, how it is done is known as a digital computer. Digital computer is a process done with the boolean values 0 and 1, and we will use 2 values. 0 is for false, 1 is for true. We will give binary format as input, and computer will understand the binary language. Digital system or digital computer both are same that performs various computational tasks. The word digital implies that the information, the word digital itself explains about the information about the computer or system is known as digital computer. It is the definition of digital computer, and in the computer is represented by variables. We will give data with storing the Data is known as variables. We will give the data in variable format, input. After giving input, it will understand it in binary code. After that, it will give us the output. This is the process of a digital computer. These values are a limited number of discrete values. We will give some limited number of discrete values for input. These values are processed internally. After giving the input, it will process the information internally and it will give us a output internally by components. Digital components that consign to take associate values. Two values is to be binary, 0 and 1. This is a process of a digital computer. In depth, digital computers are used the binary number system. It is done with some different components, like we will use binary, octal, decimal, hexadecimal. These are the binary number systems. We use these binary number systems as input for the digital computer, which have it is used in digital electronic devices also, and we will give the information in zeros and ones. Binary digits is also called as a sort. It is a process of giving the information in zeros and ones. Information is represented in digital computer in group of bits. We will give it in group of bits format. After understanding it in internally, it will give us a output. Using various coding techniques, groups of it can be represented by binary numbers, discrete symbols. We will use some Boolean symbols like and or, not, exclusive or, exclusive and nor, gates. We will use different types of input giving systems. Decimal numbers are used as a base 10 system. Decimal means 0 to 9. We will give it with a symbol base 10, representing the variable base downside 10 power for decimal. For binary, we will take 2. For octal, we will take 8. For decimal, 10. For hexadecimal, we will take 16. These are the binary system representation techniques. This is a block diagram of computer. In first step, memory is there. Memory is present. Random access memory. After that, it is connected to CPU, central processing unit. It is connected to IOP, input and output processor. It is between input device and output device. This is a block diagram of computer. It is important for short question. Try to remember this block diagram of computer. If they asked about computer means better to write this block diagram and explain it with detail. RAM is the memory, is used for storing purpose. It is for processing purpose. It is lies between two devices, input and output devices. This is a block diagram. So you need to describe it with in your own words. It is better to remember this diagram. It is an important concept, RTL question. Register transfer language. Name itself explains about the concept. It is a process of storing the information in register format and transferring with a symbolic representation with location arrow marks from where to where is known as a register transfer language. Register transfer language is a symbolic location is used to describe the micro operations like adding two registers and transferring from where to where, which register to which register. It is transferring the information. We have some micro operations. Transfer among the register is known as a register transfer language. It explains about the register storing data purpose and it is used for micro operations for transferring the data among the registers, different registers. is known as RTL. It implies the availability of hardware logic circuits that perform a stated micro operation and transfer the result of the operation to the same or another register, whether it is shared among registers or shared within the register with some operations. We are transferring the data from same or another register. It is a process of taking some hardware logic circuits and drawing a symbolic representation is known as a register transfer language. We use it with some register techniques, flip-flop techniques and micro operations. In depth, register transfer language is included with a register topic. It is a group of flip-flops. It is giving information with zeros and ones as an input, with each flip-flop capable of storing one bit of information. Blindly, you need to remember this concept. Register is used for storing the data. In which it is storing? It is stored in flip-flops. What are flip-flops? Flip-flops are zeros and ones. For each flip-flop, we have capable of storing one bit of information. This is the main important point in this concept RTL. An n-bit register has a group of n flip-flops. For one flip-flop, for storing one bit of information, we use one flip-flop. For n-bit information, we use n flip-flops. It is capable of storing any binary information of n bit. If n is equals to 0 to 1 so on up to how much means so on infinite. Computer registers are designed by capital letters. It is always represented with a capital R symbol. It is not represented with a small letters. Sometimes followed by numbers also to denote the function of the register. If we have 5 registers means we will represent it with capital R1, capital R2 up to so on capital R5. So this is a representation of registers with the capital numbers followed by numbers, capital letters. This is the representation. Example, MAR. M stands for memory, A for addressing, R for register. It explains about the address of the register stored in memory. PC is the program counter. It is represented with n-1. N is the number. It is decreased with 1. IR is the instruction register. It will follow the instructions for performing the tasks. R1 is a processor register. So these are the examples of registers in register transfer language. So this is the information, and we have one block diagram for representation of registers. Block diagram of register. It is a representation of registers. R1 is a register. This is a individual bits stored in register 0, 1, 2, 3, 4, 5, 6, 7. From right to left we will start in right and we will go for left side. For storing the bits, we are storing individual bits from 0 to 7. Total 8 bits we are storing. Starts with 0 and ends with n-1. Here 8 terms, so 8 minus 1 is 7. We will start with 0 and end with 7. This is the representation of a R1 register. For suppose we have storing 16 bits means we will represent it with 0 to 15. 0 is the starting element, 15 is the ending. 0 to 15 we are storing 16. Last element is n-1. 16 minus 1 is 15. So this is the representation of registers. P of H, PC of H, PC of L. PC is the program counter, L is the low, H is the high. From 0 to 7, 8 elements is stored in low, 8 elements stored in high, 8 to 15. So these are representation divided into two parts. Here we are represented with individual bits. Here we are separated. It is divided into two parts, 8 and 8, total 16. Number of bits is 16. We have divided into two parts, 0 to 8, 0 to 7, 8, and 8 to 15, again 8, total 16. The individual flip-flops into an n-bit register are numbered in sequence from 0 through n-1. Starts with 0 and ends with n-1. Starting from 0 in the rightmost position, that is right side, and increasing the numbers towards the left. Here we are storing 0 to 7, total 8 means starts with 0, rightmost position, and moves towards left. 1, 2, 3, 4, 5, 6, 7. So we are moving rightmost position to left side. This is the representation. Most common way to represent a register is by rectangular box. We will represent it with by rectangle with two sides same. It is known as birectangular box with a name inside. We are representing with R1 register means R1, R2 means R2, like that. Register transfer. What is the term register transfer is used? It is used for information transfer from one register to another register. Is designed in symbolic form by means of a replacement operator. Replacement operator is the arrow symbol. In register transfer language, in a computer organization architecture subject, we will represent it with starts with rightmost position and goes to left side. We will represent it with R1 register is a replacement operator with R2 register. R1 is replaced. R1 is transferred the information to the R2 register. So this is the register transfer language. This is a symbolic representation. This is for register transfer. For RTL, register transfer language, we will represent with birectangular and storing the data with capital letter and with followed with numericals. And we will start with storing representation rightmost position to left side. This statement denotes the transfer of the content of R1 into R2 register. R1 register transferred to R2 register with the replacement operator. Replacement operator is the arrow symbol. We have control function. If p equals to 1, then R1 transfers to R2. This is a replacement operator. We want to transfer the data to occur only under every determined control condition. If then statement is used. P is control signal. In the control section of a control function is a boolean variables. It is a control function representing with the register transfer data. The control condition is terminated with a column. It is executed only if p equals to 1. If a p equals to 0 means or other values means it is terminated. If a p equals to 1 means it is represented with this p of R1 transfer to R2. This is the representation. Block diagram of control function. This is a diagram. Control circuit is present in block function and it is connected with registers R1 to R2 and it is connected with the clock in the right side. Clock is the representation with the increasing incremental function. Load is for giving the load data with the transfer occur. This is the representation arrow mark. This is a control function. The R1 register is transferring the data to R2 register and n outputs of R1 register are connected to n inputs of R1 register to R2 register. N is the representation of n outputs and here n means number of bits. register R as load, it is given as input, is activated by the control variable P. If P is possible as a one value, then we can write a control function. If P is not equals to 1 means it is terminated with a column, and the control condition is not taken as consideration, and we will give load as an input. It is a main function for activating the control function for control variable P. Control variable P is synchronized when it is transferred with the same clock applied to the register. Control variable is a representation of P. It is transferred or it is used for transmission with the same clock applied to the register. It is applied same for the register, and it is used as activation function. When coming to control section, for clock pulse we will increase the edge. We will raise the edge from T to T plus 1. We will increase each step with a plus 1. It is used for load input activating process, and P may go back to 0 at a time T plus 1. In some cases, P will go back to the original value as a 0 in coming to T plus 1. So this is the full information of register transfer. We have some basic symbols for register transfer. Letters and numbers are used for denoting the register, like MAR, R1. Memory addressing register as R1. Parenthesis is used for part of the register representing purpose. R1 is for low, R2 is for 0 to 7 elements. Arrow, it is the conditional operator, is used for transferring the information from R1 register to R2. Comma is used for separating the registers included with the conditional operators. Separates two micro operations. This is the symbol, this is the description, this is the example. This is total overall information of a register transfer language. This is a diagram of a 4-bit common bus. We have 4 multiplexers. It will take multiple inputs and gives one output. Multiplexers are MUX representation with 0, 1, 2, 3 values, and A1, B1, C1, D1. These are the values connected for representing the multiplexer inputs. First, these are all connected with one common thing. These all connected with registers, R1 register, R2 register, R3 register, R4 register. Registers are represented with 0, 1, 2, 3. Bus and memory transfer. It is a process of representing a digital computer, difficult digital computer, as many registers, and paths must be provided to transfer the information from one register to another register by using one formula. 2 power n is the input. N is the input value, n is the selection line. We will calculate it with 2 power n. The number of bytes or collection of bytes is known as bus or bunch of bytes. Generally we use bus in a COA subject. Bus is the representation of number of bytes together will be excessive if separate lines are used between each register and all other registers in the system. This is a process of connecting all the wires or a bus for separating the lines used between registers R1 register, R2 register, R3 register, R4 registers. It is used in multiplexers. A more efficient scheme for transferring information between registers in a multiple register configuration is a common bus system. Common bus system is a definition of multiplexers and registers connection purpose, taking multiple input values and giving one output is known as common bus system. A bus structure consists of a set of common lines. Generally, bus system or a bus structure is a set of common lines representation, one for each bit of a register through which binary information zeros and ones is transferred one at a time. The control signals are given for the bus system used for determining the registers for selecting by the bus. These are the inputs, these are the outputs, these are the process of transferring the registers for exchange or exchanging the data. One way of constructing the common bus system construction, each register has 4 bits numbered 0, 1, 2, 3. These are the 4-bit numbering system and 2 selection inputs S1 and S0. These all are connected at the top of the multiplexer. First we will connect the registers. After that the multiplexers will be present at the top. S1 and S2 are selection inputs connected to the multiplexers. Multiplexers are connected with numericals 0, 1, 2, 3 and these are connected with registers R1, R2, R3, R4 registers. For an example, output 1 of A is connected to the input 0 of multiplexer. 1 because this input labeled A1. In simple words, you can attempt the question with knowing the terms from what is the term, what is the element for which it is connected, what is the purpose of connecting the element. From the diagram shows the bits in the same significant position in each register are connected to the data inputs of one multiplexer to form one line of the bus. One multiplexer is used for one line of the bus representing purposes and it is used with registers transferring the data. Multiplexers are the taking input values, multiple input values and giving one output. Those are connected to registers. It is numbered with 4, 0, 1, 2, 3. First you need to draw the diagram. After that you need to explain all these terms. Maximum 0 multiplexers, the 4 bits of a registers, max 1 multiplexers, multiplexer 1, the 4 1 bits of the registers are similar for the other 2 bits. The process is the same for all the multiplexers and registers. The selection inputs are connected to the multiplexer. It will take the multiple input values and gives one output value. After that it is connected to the registers. This is the process of common bus system. Each multiplexer has inputs 0, 1, 2, 3. Registers also has inputs 0, 1, 2, 3. Here we use 4 inputs for multiplexers and registers. These are the terms included for common bus system. The two selection lines S1 and S0 are connected to the selection input of all 4 multiplexers. When S1 and S0 are equal to 0, 0, the 0 inputs of all 4 multiplexers are selected and applied to the outputs of that form of the bus. So this is the explanation of the diagram. Similarly, register B is selected to S1 S0 equals to 0, 1 and so on. We will take these values 2 power n. This is the formula we use for solving these cases.